Hi, we're the Ocean-Going Robots ECE Capstone team. We consist of Malachi Fisher, Grayson Lewis, Miles Drake, and Samuel Barton. Our project is to develop a system to measure swell amplitude, direction, and period of waves from an ocean-glowing glider as it floats on top of the ocean while consuming a minimal amount of power. Goals we met from the previous week include finishing drafting section 2 of our project document, which included creating a first draft of our project requirements, design impact statement, risk assessments, references and file links, and of course a revision table. Going to lab to take measurements of the glider science bay so that we can design an appropriately sized PCB to mount the sensor hardware onto. Reviewing design artifacts from the previous year's Capstone team for component selection, power requirements, etc., and identified improvements that could be made into our system. And we also met with the CS team and our project partners to go over the project progress and coordinate future work for the project. As for our project document, we completed drafting section 2, and completed the second draft of section 1. We developed the primary stages of the project document, which included potential risks that might be encountered during this project, and we documented them based on the probability that they'll happen. We still need more information on technical requirements such as SD card size and data transfer speeds.
Last Friday, we met with the project partner to open up the glider and take some measurements. We measured a few different potential areas where the PCB to be developed could be mounted. We decided that we'll have separate PCBs for the microcontroller and the sensor and for the SD card. We identified 2 possible locations for the SD card PCB and 4 possible locations for the microcontroller and sensor PCB. As you can see in the picture on the left, the locations colored in blue are the possible locations for the microcontroller board. And on the picture on the left and the right, the locations colored in red are the possible locations for the SD card board. We kind of decided that the center blue location was where we wanted to put the PCB.
This past week, we reviewed some of the design artifacts from the previous year's team. We looked at the schematic and the PCB from the previous year, and we decided to use largely the same chips as last year, as that allows us to remove a significant amount of risk from our design while we're starting from a solid foundation to build our project from. We're in the process of sourcing development kits. This is going to allow us to test the previous year's firmware, identify any errors, and optimize it and modify it for this year. We're also evaluating buck regulators to step down the input voltage, which is anywhere from 5 to 17 volts and needs to be stepped down to 3.3 or below. We are evaluating the LM2576, the TPS 277451, and the TPS 54232. We're going to be evaluating these for high efficiency because our application requires that our entire system draws a very small amount of power, so we want our regulator to be very efficient.
So as Grayson said, we were able to see the PCB files from last year. These are the 3D models that we found on the Fusion 360 file. So on the left-hand side here, you can see the STM32 microcontroller, the SD card holder below it, as well as the XSense MTI3 accelerometer and MEM sensor on the right-hand side. The STM32 is kind of the center of the whole design. It's going to interface both with the XSense sensor, the SD card, as well as many other components in this design. Other than that, we'll be adding in, I believe, on the top left of the left picture, the power supply or the buck converter.
We had a meeting with the CS team and our project partners last week. We scheduled a recurring meeting for both the ECE team and the CS team to get together with the project partners and go over challenges, progress, and questions as a group. So we agreed on a format for the meetings going forward. We gave them a progress report and we got some questions that we wanted answered. Our goals for next week are to start working on the block diagram of our system. We're going to buy some STM32 chips as well as a couple of eval boards. We're going to refine our requirements and risks in the project document section 2 in preparation for the final draft submission. And we're also going to select and procure a buck converter.